Now we will continue with tutorial number 1, hydrostatic force in curved surface. Figure below shows an oil reservoir with a 10 meter long curved gate. This can be denoted as A or L. That is hinged at point A. Determine the resultant force Fr exerted by the oil on the gate and the angle of application if the depth of the oil, which is having a density of 850 kg per meter cube, in the tank is 9 meter. So the total depth from the top or the surface of the liquid to the floor is 9 meter. So if we add up, 4 plus 2 is 6 plus 3 is 9 meter. Okay, so the radius over here is 2 meter. And first, what we need to do is we need to draw the volume for the picture. Okay, so the volume will be drawn like this. Okay, and if we bring out the volume, it should look like this. Okay, so we just add up all the force acting toward it. Sorry, this is Fy, this is Fx, this is W, this is Fr, this is Fv, and this is Fh. So all together we have 6 of them here. Now we will continue and calculate for Fr by studying the components that we have over here. First, we have summation of Fx equals to 0. So we will have from the picture negative Fx plus Fh equals to 0. So Fh is equal to Fx. If we remember from the theoretical part, where when we have this, we need to represent the lines with a rectangular shaped plate like this, and we need to make sure we know what is the S. S over here should equal to 4 because this is from the tip to the surface of the liquid. So S is 4 meter and the radius here is equal to 2 meter. So S is 4 meters, R is 2 meters. To continue with this, we have to find out what is YC. YC is equal to S plus the radius divided by 2. So equal to 4 plus 2 divided by 2. So YC is equal to 5 meter. Okay. And then when we find out 5 meter for YC, we can find what is Fr. Fr is rho times G times YC sine 90 degree A. So it should equal to 850, 9.81. YC is 5 meter. Sine 90 is 1. The area should be 2 times 10 meter. Okay. So Fr should be equal to, let me do the calculation. $833,850 Newton. That will be the Fr, or I'm sorry, this should be the Fh. Okay, so resultant force, or we call it as Fh here. Okay, so the next one, we will have the second calculation. This is based on the summation of Fy equals to 0. So here, summation of F in the Y direction equals to 0. From the picture, we'll have positive Fv minus Fy minus W equals to 0. So Fv is equal to Fy plus W. So to find out Fy, we do calculation in terms of horizontal plate, which is, this is the HC. Okay, and the HC should be also 4 meter. Okay, because the surface or the horizontal line over here is at the top, so the distance is 4 meter. So to find out Fy, it should equal to rho g HCA, which is 850 multiplied by 9.81. HC is 4, A is 2 times 10. Okay, if I calculate the numbers, should equal to Fy. It is 667 and 80 Newton. Right? So we have already calculated Fy. Now we have to calculate W. So W is rho times G times V, and this is a quarter circle, so the V is pi r square over 4 multiplied by A, so equal to pi. R is 2 square over 4 and A is 10 meter. So pi times 2 square times 10 divided by 4. So the answer is 31.42. So the volume is 31.42 meter cube. Okay, so from there we'll do this calculation. W is equal to 850 times 9.81 times 31.42. So the answer should be W equals to 261961.7 Newton. So Fv is equal to Fy plus W. This is from summation of Fy equals to 0. So equals to equal to 667,080 plus 261,961.7. So Fv should equal to Fv equals to 929,041.7 Newton. Okay, when we get both Fv and Fh, so we can do the calculation for Fr. To find out Fr, Fr is equal to Fv square plus Fh square and square root of it. So Fr is equal to, square is 929,041.7 square plus 833,850 square. So the Fr is equal to 124,8368.66 Newton. That will be the answer for Fr. And for theta, it is theta is equal to inverse tan Fv over Fh. So equals to inverse tan. Fv is 929,041.7 divided by Fh, which is 833,850. So theta is equal to 48.09 degree. Okay, so if you want to do the representation of the picture here, it will be equal to this picture. The volume is here, and then the FR should be here. FR should be equal to 1248368 Newton, and the FH should be here, and the angle theta should be here. Okay, so that covers tutorial number 1, hydrostatic force in curved surface. Now we will continue with tutorial number 2, hydrostatic force in curved surface. A 2 meter wide quarter circle, so this should be a gate of radius of 1.8 meters, so this is the radius, is hinged at point B as shown in figure below. The gate controls the flow of seawater, so the density of seawater is 1025 kg per meter cube over the ledge at A. So determine the resultant force subjected on the gate with its point of application. So this is almost the same as before. Right now what we need to do is, first we have to draw the volume. So the volume looks like this. So if I bring up the volume to the other side, it will look like this. Okay, it's no longer a quarter circle, so we just have FR acting on it. We have FV, and then we have FH, W, Fy, and Fx. So all 6 forces are acting here, and then we need to know the distance between point A to the top to ease our calculation. So because the radius is 1.8, so distance from here is 1.8. So from the surface to point A, it should be 3.5 minus 1.8. So it should be equal to 1.7 meter. Okay, so continuing with this, in order for us to find FR, as usual, we have to do summation of Fx and summation of Fy equals to 0. For this one, Fx equals to so Fx minus Fh equals to 0. So Fx equals to Fh. Okay, so we have this relationship. Now to find out what is Fx, we need to draw the vertical representation in terms of a flat plate. Okay, so S over here is 1.7 meter, so the radius is 1.8 meter. So here is where you have your Fx. So the Fx should equal to rho g yc sin theta A, but first we need to find out yc. Yc is S plus R over 2 equals to 1.7 plus 1.8 divided by 2. So yc should equal to 2.6 meters. Okay, and then based on this, we will continue and calculate at the top here. So to find out what is Fx, Fx is equal to rho g yc sine 90 degree A, which is equal to, this density is 1025, 9.81, yc is 2.6 meter, sine 90 is 1, A is 1.8 times 2 meter. So fx should equal to right, so fx should equal to 94,117.14 Newton. So we are done with fx. Now we do summation of fy equals to 0. Let me change the color first. So summation of force in the y direction equals to 0. So from the picture, we'll see negative fy minus w plus fv equals to 0. So fv is equal to fy plus w. Okay, so this is the relationship for y direction. So to find out fy, we do the horizontal plate calculation. This is hc, which is equal to 1.7 meter also, because the plate is at the top and to the surface. So this is the horizontal plate representation. So hc over here is equal to 1.7 meter because the distance is from the top part of the volume to the surface. Okay, to find out what is fy, it is equal to rho g hca, which is equal to 1025 times 9.81 times 1.7 times 1.8 times 2. So fy should equal to 025 so it is equal to 61538.13 Newton. So that will be for fy. Now you will have to find out w. Okay, for w, it is equal to rho times g times v. Okay, so v for this picture, because this is not a shape of a quarter circle, the shape is like this, so we will have to use r square minus pi r square over 4 multiplied by a. So this is equal to pi is 1.8 square minus pi, 1.8 square divided by 4 multiplied by 2. Okay, so this will be for the volume. Okay, so volume will be 1.39 cube. So putting back the number here, we'll get 1025 times 9.81 times 1.39. So W should equal to the answer should be 13,983.03 Newton. So this will be for W. So when we are done with that, remember we need to add up the weight and also we need to add up the weight and also Fy. So based on this equation, Fv is equal to weight plus Fy. So this is equal to weight is 13983.03 plus Fy is 61,538.13. So the answer will be Fv should equal to 755.21. Fv should be equal to 75521.16 Newton. Okay. Now to find out Fr, it is just a calculation of addition between two squares over here. So Fh square plus Fv square and square root. And the answer for Fr should be Fh or Fx 94,117 for square plus 75521.16 square and then square root of it. So Fr is equal to so Fr is 120,670.96 Newton. Okay, so find out theta is tan inverse or inverse tan Fv over Fh. So if we do the calculation, 75.5 to 1.16 divided by 94,117.14 reverse answer. So theta should equal to 38.74 degree. So this should be the answer for tutorial number 2. If you want to do some representation for the volume, it should be this. So the Fr is here. This is the Fh, and this should be theta. Okay, so that will cover the answer for tutorial number 2, and I hope this should be beneficial for you in order for us to study or to calculate different type of hydrostatic force and curved surface. So thank you.